This is question 2 of the 2022 O-Level A-Math paper 2. It is given that fx equals to x cubed plus ax squared minus 3x plus b, where a and b are constants, and this polynomial has a factor of x plus 2 and leaves a remainder of 30 when divided by x minus 3. Okay, so I want you to see these two pieces of information as separate. Okay, so the factor of x plus 2 and the fact that this polynomial leaves a remainder of 30 when divided by x minus 3. Okay, these should give you clues that your question is on remainder and factor theorem. So let's first recap what your remainder and factor theorems are. So firstly, the factor theorem tells you that if fa equals to 0, you can conclude that x minus a is a factor of fx. Next, according to the remainder theorem, if fx is divided by x minus a, you will get a remainder that's equal to fa. Okay, so let's apply these theorems to this question. Okay, first of all, we're going to use the factor theorem. So using the factor theorem, so you have a factor x plus 2 here, okay? Which means your a is negative 2. So basically, f negative 2 will give you 0. So when you sub in negative 2 into all the x's, you will get 0. And then you just simplify this equation. Okay, so you get your first equation. Secondly, let's use the remainder theorem. So because here your remainder is 30, right? You know that fa will be 30. So what is a here? The a is 3. Okay, so f3 is equal to 30. So this is your second equation. Then you solve these two simultaneous equations, okay, number 1 and number 2. So you can get 2 minus 1, equation 2 minus equation 1. That will give you 5a equals to 10. So a is equal to 2. Okay, then you substitute this value of a into either equation number 1 or equation number 2. I'm going to substitute it into equation number 1. Okay, so from 1 so b is equal to negative 6. And those are your two answers for a and b. Right, next, using these values of a and b, factorize fx completely into 3 linear factors using surds where necessary. When you want to factorize a polynomial of degree 3, you can expect there to be a maximum of 3 linear factors. Okay, and you know that 2 linear factors when multiplied together, give you a quadratic, right? So if you already have one linear factor, you can first represent that polynomial of degree 3, in terms of one linear factor times a quadratic. And then you further break down that quadratic into two linear factors. Okay, that's what we're going to do. And that's a pretty standard method of factorizing a polynomial of degree 3 into three linear factors. Okay, we already know one linear factor because the question already told us that x plus 2 is a factor of the polynomial. So we know that x cubed plus 2x squared minus 3x minus 6, which is the polynomial they gave us, is equal to x plus 2, which is a factor of it, times some quadratic that we don't know yet. Let's just call the quadratic ax squared plus bx plus c. This is the general form of any quadratic. We just don't know what the a, b, and c are yet. And that's what we're going to solve. Okay, first, we're going to compare the coefficients to solve for a, b, and c. Let's compare the coefficient of the x cubed term. You can see on the left-hand side, it's 1, right? The coefficient of x cubed is 1. Okay, so we know a is equal to 1. And then you compare the constant term. On the left-hand side, it's -6, and that is equal to 2 times c. Only this pair gives you the constant term. Okay. So 2c equals to -6. C is equal to -3. Then next, let's compare the x squared term. And to get the x squared term, we can get this constant 2 multiplied by the ax squared, and also x multiplied by the x term. Okay, so 2a plus b will give us the x squared term, which is 2. We know that a is 1, so 2a will be 2, right? So 2 plus b equals to 2, that means b is equal to 0. Okay. So therefore, your polynomial is equal to x plus 2 times x squared. Since b is 0, there's no x term, and c is -3. Okay, is this the final answer? It's not, because you can further factorize x squared minus 3 into two linear factors. So recall your a squared minus b squared. So now your 3 is a square of its own, okay? So if you have to square root that, you'll get x plus 3, x minus 3. Sorry, x plus square root of 3, and x minus square root of 3, because you have to square root the 3. The 3 itself is already the square. Okay, and that's your final answer for this question.